Welcome back to Spring into Math 7. I'm Mrs. Campbell, and today we're going to be talking about solving inequalities using addition and subtraction. So let's jump right in. So quickly, I want to do a review of our inequalities symbols, which we talked about in our last video. This is the greater than symbol. We have less than, greater than or equal to, and less than or equal to. So for example, when we have 2, and that symbol x, that is telling us that 2 is greater than x. Or y is greater than or equal to 5. Also wanted to take a minute to review how we graph inequalities. And we talked about circles in our last video, that an open circle tells us that the value is not a solution. Like we have here, n is less than 2. So that circle will be open because 2 is not a part of the solution. However, if we have n is greater than or equal to -4, then our circle will be closed or filled in because the value of -4 is a solution of the inequality. Okay, so sometimes inequalities are actually not as straightforward as x is greater than 4. Sometimes we actually have to solve the inequality like this. X plus 3 is greater than 7. So we need to figure out the set of numbers that will make this a true statement. Now, how do we do that? Well, knowing the addition properties of inequalities is helpful. The addition property of inequality is helpful. If the same number, it tells us that if the same number is added to each side of an inequality, the sense of the inequality stays the same. And that is that the inequality symbol does not change. Let me show you what I mean by that. If A is greater than B, okay, then A plus C will also be greater than B plus C, assuming that C is the same number. If A is greater than or equal to B, then A plus C will be greater than or equal to B plus C. And the same is true with less than and with less than or equal to symbols as well. The subtraction property of inequality basically tells us the same thing, but with subtraction. Okay, it tells us that if the same number is subtracted from each side of the inequality, the sense of the inequality stays the same. That is, the inequality symbol does not change. So if A is greater than B, then A minus C is going to be greater than B minus C. And same thing with greater than or equal to, and same thing with less than and less than or equal to. Okay, so let's take a look. I wanted to give you two examples of one of each, one of the addition property of inequality and the subtraction property of inequality. So with addition, if k is less than m, then k plus 14 will be less than m plus 14 because, as we said, k is less than m. Same thing with subtraction. If x is greater than or equal to y, then x minus 8 will be greater than or equal to y minus 8 because x is essentially, and always, in this case, x is greater than or equal to y. Okay, solving inequalities using addition or subtraction. This problem is asking us to solve and graph n minus 3 is less than 5. All we need to do, the same way we would with an equation, we're trying to isolate that variable. We're going to add 3 to both sides of the inequality, and we have, the problem was n minus 3 is less than 5, plus 3 to both sides of the inequality, and I get n is less than 8. And it would be graphed this way with an open circle because n is not part of the solution. 8 is not part of the solution. All right, now you try. See if you can solve and graph. -2 is less than or equal to x plus 4. Good luck. Welcome back, everyone. How'd you do? Let's take a look. So our original problem asked us to solve and graph. -2 is less than or equal to x plus 4. I want to isolate that x, so I'm going to subtract 4 from both sides of the inequality. Just to make things simpler, instead of subtracting 4, I added a -4. So I have -6 is less than or equal to x. So when we graph this, we're going to use a closed circle because -6 is part of the solution. All right, here's a word problem involving inequalities. AJ is buying decorations for a school dance. He will spend $10 on balloons and X, our variable, our unknown, dollars on streamers. At most, he could spend $18 on decorations. You are asked to write an inequality to represent X the number of dollars he could spend on streamers. Could AJ spend $8 on streamers? Explain. Okay, so what I like to do is I like to write out the problem in words as a math problem with words kind of, and then plug my numbers in. And the way that we did this one is the balloons and streamers, at most he can spend $18. So we know that he's spending $10 on balloons, and tells me to add the streamers. I don't know, that's my variable, that's X. At most, I will use the less than or equal to sign. He can spend $18. And now I have my inequality written out, and I simply have to solve. 10 plus X is less than or equal to 18. I'm going to add 10 to both sides of the equation, and I get X is less than or equal to 8. So AJ can spend $8 or less on the streamers. All right, everyone, that just about wraps it up for this lesson. Thanks so much for joining us, and we'll see you next time.